Hello guys, and in this video I'm going to talk about my helmet collection, my Barak Table of Helmets collection I should say, and I'm going to show you guys what helmets I have collected in the last 1 to 2 years. So here we go. So the first element I will show is some lithium there. You can see it has like a black metal there floating in this mineral oil. Looks like my bottle's leaking, so I'm going to put it in a different container or fix the leak. Anyways, there's some nice lithium. The black coating you see there isn't the actual metal, as you may know. It is a coating of lithium nitride, because lithium reacts spontaneously with the nitrogen in the air. There also might be some oxides on that. I'm not sure about that one there. Also could be lithium hydroxide on there too, because it does react spontaneously with water in the air. And of course, as you may know, it reacts very violently with water, if there's enough of it, if there's enough water anyways. So there's some lithium there. Wipe my hands off here, because this mineral oil is all over me here. Need to fix that leak. Next is some sodium. My focus is horrible. Sorry about that, but this camera is very terrible with focusing. I've got another camera I can use, but it is currently dead, so I had to use my least expensive camera, which is absolutely garbage, in some ways more than others, of course. But anyways, there's some sodium metal. This is sodium metal, and the white coating there is sodium hydroxide and possibly also some oxides, of course, because it reacts with oxygen in the air and also some water in the air, which is where the hydroxide comes from. And of course, it will react violently with water. If you drop it into water, if you have enough of it, it will explode. So if you do mess with sodium metal in large quantities and putting it in water, please do be careful, because sodium is quite dangerous, and yeah, and I will not hold responsibility for anybody getting hurt if you try it. So anyways, moving on to the next element, and that would be some beryllium. You may not see it because this is kind of a black background here I have here. Most people might know that beryllium is quite toxic, poisonous, whatever, but that's normally if you inhale it as a powder, like if you grind it up and inhale it, which most people don't go around doing that anyways, unless they're crazy or something like that. Anyways, not saying that there's anybody crazy out there, but I'm sure there is. Probably a few, but don't know who would try that at all. But anyways, as a piece of solid metal, it's quite safe. Just as long as you don't grind it into a powder, you're fine. But I'm still gonna wash my hands after I get done with this video, especially since farther along in the video there'll be more poisonous ones, even more poisonous than beryllium. Moving on, the next element is some good old magnesium here. A lot of people know about magnesium because this also has some use in building electronics, like cases for things like phones and so on. And also, people might know it as when you burn it, it produces a really white, bright flame. I might show a video of that in the future. But anyways, and you burn it and it creates magnesium oxide, which is a whitish powder. Anyways, as a metal, it's very light, which is why it is used in making covers for, like cases for phones and some laptops are made of, covers of laptops are made of magnesium as well. So there's some beautiful magnesium. Sorry if the picture quality isn't that well, but this is a quite cheap camera. The next element is some niobium. It's a quite shiny metal. It's not quite silvery like most metals, but it's kind of like a grayish kind of a shiny metal. It also has two names. Most people call it niobium, but some people, like maybe scientists, chemists, might call it columbium, because that's another name. Not very many people know of the name of columbium, but makes me kind of curious how many people call it columbium. So let me know in the comments below if you call it columbium or niobium. I'll be quite interested of what pops up, or who says which name, columbium or niobium. Anyways, moving on. And I'm quite alright with the other name as well. So, but I think the name niobium is quite more unique than columbium. But anyways, the next element is osmium. You may or may not be able to see that. This camera is, again, horrible at focusing. You might be able to make out its blue, bluish silver luster. This is only 0.3 grams or so. It is quite expensive. It's just on the right. It's on the right-hand side of the platinum group metals, which would be like, of course, platinum, palladium, rhodium, ruthenium, and I don't know if ruthenium is considered a platinum group metal, but metals like rhodium and iridium and platinum and palladium are what they call the platinum group metals. This is just on the right-hand side of that, so on the periodic table. But anyways, very expensive metal. Like, I don't know, 6 grams is like almost $100, so quite expensive. So this is only 0.31 grams. Anyways, moving on. The next element is some zirconium. Things falling over here. Some zirconium metal, which is a quite metallic. We unfold this here. I'm not going to take it out, but I just noticed that it was folded, so hold on a second. There we go. It is a quite shiny metal. I think it looks like it has kind of maybe a very slight yellowish tinge to it. I don't know if it's just me, but in the camera it also kind of looks that way, so I don't know. But otherwise, it's kind of silvery and a very nice shiny metal. This is a foil, so it's quite flexible as a metal as well. This is some info there. It won't focus. Basically, it just says, its name and its symbol ZR. It has a atomic number of 40, and it melts at 3,371 degrees Fahrenheit and so on. Got it from United Nuclear. There's a website there if you can read it, but I'll put a link down below if you would like to visit them. Anyways, moving on. The next element is some silver, some wonderful silver. Of course, a lot of people know about silver because it's used in jewelry and so on. I obtained this silver, kind of by buying it, but I didn't obtain silver metal, like silver metal itself. I didn't buy silver metal. I bought silver salt, and then I obtained silver from that. I reacted silver nitrate with some copper, and just copper wire, and I just made a solution of silver nitrate and dangled a copper wire into it and waited a few hours. And I was greeted by silver crystals, and then I just melted it down into this nice lump of silver. I also got a little bead right there. Anyways, that's some wonderful silver. There's kind of a close-up look at it if it will focus. And it's not focusing, so I'll just put it way out here. You can see it's nice, silvery, shiny metal. And it's quite a lot stronger than I expected. I expected it to be kind of like gold and kind of be soft, but I don't know. Thought it was supposed to be malleable, but I think I might be thinking of gold, so, in which I don't have any, which is sad, because gold is very beautiful metal. Anyways, moving on. The next element is some copper. This is a quite heavy piece of copper. Don't know how much it weighs. I think it might weigh about 100 grams or more. Dropping it. Anyways, so this is a nice big lump of copper, which, as you know, it's used to make copper piping for houses and so on, and also electrical wiring for houses as well, and other electronical applications. Moving on, we've got some. Next up, I got some lead, some beautiful big lump of lead. It's quite a nice bar of lead here. I made myself by melting down lead and pouring it into a wooden mold, which is not such a bright idea because wood's flammable, but I still made a quite nice mold for lead. It didn't smell too good. Anyways, very heavy, very dense. Probably weighs a pound or more, maybe 2 pounds, even though it is quite thin. And underneath that, since the next one is a radioactive mineral, underneath that I have the next element, which is again radioactive. This is a radium. This is in the form of a clock number, in this case the number 3. And it is fluorescent, or phosphorescent, or whatever the name of that is. It's not radioluminescence. That'd be caused by the actual radiation itself, which if you could magnify it to a really high magnification, you might be able to see some radioluminescence from that, or scintillation flashes. But anyhow, I can demonstrate that it is phosphorescence or fluorescence, luminescent. But anyways, so I've turned on my black light here, which you may notice. And if I look up here, there's my black light, and I'm going to zoom in here. And if I reach over here and put it underneath the black light, you may be able to see it glowing green there. Kind of looks blue in the camera, but trust me, it's very quite green. It's kind of like a grass green kind of green. But anyways, let's put that back down, and let's test how radioactive it is. Readjust my camera here. So let's test how radioactive it is. Over here, off to the side, got my trusty CDV 700 Geiger counter here. So let's turn it on. And I hear the buzz from it. So I need to fix my adapter because it's kind of intermittent. So we may or may not hear sound from this. We could test it by using the check source. Oh, that's tangled. Hold on. Oh yeah, definitely working. Anyways, we're gonna switch it to times 100. Yeah, it's gone off again. Let's just set it. Yeah, my sound's not gonna work now. Oh well. Not seeming to want to work. I'll just unplug my sounder. We don't need to hear sound. Hold on a second. Sorry, I'm taking too long here. Anyways, I'm just trying to keep this video as short as possible, but as you can see, it's around 15 minutes now. So, anyways, so here's our probe of our CDV700, and has a beta shield and so we can just measure gamma, or we can undo the beta shield and expose the tube so we can measure beta. Which you can watch my other video you can watch my CDV700 video to learn more about the CDV700. But anyways, so I'm gonna point the camera at the meter here. Hopefully I can maybe set this up here. Probably can't read the numbers, but I'm going to point to it anyways. On times 1, if I get it near the radium clock hand, or clock phase, or clock number I should say, it maxes out times 1. If we switch it to times 10, let it settle down a little bit, and put it onto the number. Oh, and by the way, it's sealed up with some tape, so it cannot contaminate my meter or my probe here. So that's all fine there. And it's almost maxed out the meter. It's at around, I'm gonna say about 200 or so, or 2,800, 3,000 counts, somewhere around there. And it's basically maxed that out, because the max reading is 3,000 counts on that metering. Okay, now we're on times 100, and handles it a lot better. And it's measuring around 3,000, I'm going to say 3,500 counts or so. So it's quite radioactive. Actually, it's more like probably 9,000, but anyhow, I'm horrible at reading that. But I would say it's pretty accurate. Anyways, we'll put that on the floor now. There we go. So anyways, back to the main point of this video. Alright, the next element is some bismuth. I got several pieces here. Here's a nice silvery lump. Quite heavy. It's actually slightly heavier than lead. Here's a beautiful crystal piece here. Let me zoom this out. Here's a nice crystal-y piece. Has the nice, don't know if you can see that, but it has the nice hopper crystals there. Very beautiful. In which the colors are created by the oxides of bismuth. And here's a little tiny piece that broke off this bigger piece, so basically that's the same piece. It is a very nice silvery shiny metal normally, unless you make crystals like this, which then it reacts with the oxygen in the air to produce these very colorful oxides. So let's move on. That is actually, bismuth has been proven to be a small amount of radioactivity, but it's just so less that it's basically stable, but it is tidbit radioactive. The next few elements are going to be more, maybe a bit more interesting. The next one is some gallium. I have it inside of a pill bottle. It actually came inside this container, and I just wrote that on there. Atomic number of 31, symbol of Ga, and there's the atomic weight. And it's a nice silvery metal. It melts at 85 degrees, so if I held it here in my hand for long enough, it would most likely melt, because the body is the temperature of the body, or the normal temperature of the body is about 95 degrees, give or take. Anyways, let's put that back in the bottle here. And move on to the next one. And great. Yep. Okay, got it. Okay. Anyways, sorry this video has been really lengthy, but I kind of start rambling about elements because I think they're quite cool. But anyways, the next one is some sulfur also from United Nuclear, which again I'll put the link below so you can check them out. And I'll just open the container. You can kind of see it down in there. You turn on my light. It's overexposing my camera. Go figure. Sorry about that. You can kind of see the nice. Here, I can put it in the lid. Some nice sulfur powder. It's really quite smelly. Got some on the paper there, but it's okay. Not toxic at all, except for you don't want to breathe it if you burn it, because it produces a sulfur dioxide gas, which will make sulfuric acid in your lungs if you breathe it. So therefore, it's not a very bright idea to breathe it in. Next element is some boring aluminum. As you know, pop cans are made of this. And matter of fact, I got this from an aluminum can. More correctly, the aluminum pop tab. Anyways, it is also a silver shiny metal, but as you can see, it has some oxide coating from when I heated it up. And you can also see I tried to, well, you could possibly see, if it would focus, that I tried filing off the coating, so it'd be nice and shiny. But I'm still working on that. Next element is ordinary carbon. This is some homemade charcoal here. It has a nice fine powder. I'm not going to touch it because it gets everywhere. But it is number, I believe it's number 6 on the periodic table, I believe. Anyways, moving on to something more exciting, or moving on to an element that I don't think hardly anybody sees. And that would be antimony. This is not antimony metal, but this is antimony sulfide, or S2SB, antimony sulfide, or more correctly, antimony disulfide. It's kind of a silvery, metallic kind of a mineral, but this is the only, I guess you could say, the only sample of antimony I have, so I'll just go with this. This mineral is also known as stibnite, if I'm saying that correctly. It looks kind of black on the camera, but it is actually a silvery, shiny kind of a element, or a mineral. And it sounds like metal if you drop it on a solid surface. So let's put that back in there. Need to wash my hands after that because antimony is quite toxic, poisonous, whatever. The next two elements are probably gonna be maybe the couple of interesting ones. The last one's gonna be the most interesting. The next one is some ytterbium. A lot of people pronounce it ytterbium, but it's ytterbium, like an I, not like a Y, an I, even though it is spelled with a Y, but it's said like an I. Okay, enough rambling about that, but it's kind of like a goldish metal. That's more like the oxides of it, but the metal in and of itself is silvery, shiny. So this doesn't look particularly exciting, but it is kind of like a crystal of it. So yeah. But now on to the most interesting sample, and that would be some uranium. Now this is not pure uranium, metal or whatever. You can buy it. You can buy that. As a matter of fact, you can get it at United Nuclear. So once again, I'm going to put the link for that below. anyways, this is autunite, which is a mineral. These are little tiny crystals of autunite, and autunite is a fluorescent or luminescent uranium mineral. There's also other ones that look similar to this, like uranosite or cersite, depending how you want to say it. And that one also glows under UV light. There's another one that's also green. It's torbernite, which doesn't glow under UV light. But besides the point, got myself a ultraviolet laser here. I'm going to shine on it. Looks kind of bluish in the camera, but here, let me scatter the light with a piece of paper and maybe you'll be able to see. Well, I can't use piece of paper because it's fluorescent. Actually, we'll use this kind of like this plastic, or like we'll use. Hold on a second. Sorry, I'm taking too long. Try to find something to scatter the light. Okay, I'll just use like a plastic bag because that'll work good enough. It'll somewhat scatter the light a bit into like a kind of a smeared dot. You might be able to see it glows green. Alright, I'll just use my main black light up there. Once again, I'll zoom this in. Sorry, this video is taking too long. I meant for it to be no more than 15 minutes long, but as you can see, it's kind of dragged on to be 27 minutes. But you can kind of maybe get my hand in the frame